All right, guys, welcome to 10.7, Factoring Special Products. And the learning target is I can factor a polynomial using the difference of two squares pattern. All right, so we've been spending so much time on the trinomials with three terms. Today I'm going to show you guys how to do binomials, meaning two terms, of a special pattern. Okay, so here's the pattern. If they are of the form something squared minus something squared, okay, so if they're both perfect squares and it's a minus sign, here's the pattern that you use to factor. It's a plus b times a minus b. Let me give you an example. Okay, so the question is, what is m squared a perfect square of? So, meaning, what squared is m squared? And you guys would say 10. And then 100. What squared is 100? And you would say 10. Right? So these are both going to be perfect squares of something. M squared is a perfect square of m. 100 is a perfect square of 10. Okay? Now when that happens, it factors in a special way. It's going to be this one plus this one, and then this one minus this one. And that is actually the answer. That's how those factor. Now, if you guys are like, well, what the heck? That doesn't make sense. Can you show me why that's true? I will. If we distribute it out, look what happens. M times m is m squared. M times negative 10 is negative 10m. And then 10 times n is positive 10m. And then 10 times negative 10 is negative 100. And you'll notice that the middle terms, negative 10m plus 10m, they cancel. And look what we're left with. M squared minus 100. So that means we did it right. Okay, so here's the pattern. It's a plus b times a minus b. So there's always a plus and a minus of whatever these were perfect squares of. Let's do one more. K squared is a perfect square of k, and 49 is a perfect square of 7. Okay? So this pattern will work. And again, the pattern is this one plus this one, and then this one minus that one. And again, if you want to check it out, it will work because the plus and the minus will cancel in the middle, and you'll be left with this. Okay, super easy, super awesome. Let's run through some more. All right, d squared is a perfect square of d. 64 is a perfect square of 8. Now, if you guys are confused at how I'm finding those numbers, here's the button that you use. You take the square root of 64. That's how I got 8. Okay, so it's what number squared is 64? It's 8. Okay, if it's d and 8, then our factors are d plus 8 and d minus 8. Okay, but this only works if it's minus and these have to be perfect squares. All right, let's keep going. M squared is the perfect square of m. 36 is a perfect square of 6. And you know the drill. The pattern says that it's the m plus the 6 times the m minus the 6. And again, if you FOIL that out, you will get back to where you started. All right, if I were you guys, I would just pause it now and do the rest and then just check them. But if you want a couple more written out, I'll do one more here. X squared is a perfect square of x, and 144 is a perfect square of 12. Okay, now once you find what those are, it's plus and minus them. Okay, so x plus 12, x minus 12. Now the last three I'm going to do quick because I think you guys get the idea. So here we go. Oh, actually, no, these are harder. 4m squared is really the perfect square of what? And it's 2m. And 9 is the perfect square of 3. Okay? And the pattern says 2m plus 3, 2m minus 3. Again, the negative 6 and the positive 6 will cancel, so you will get back to where you started. Okay, 5. 16x squared is the perfect square of 4x. And then y squared is the perfect square of y. And then if you draw the parentheses, it's 4x plus y, 4x minus y. Really easy pattern for these. All right, guys, last one. 9p squared is the perfect square of 3p. Now this one, 25z to the 4th is the perfect square of 5z squared. All right, so when you write them as factors, it's 3p plus 5z squared, 3p minus 5z squared. And again, if you want to check, FOIL it out, you will get back to where you started. All right, that's it, guys. That is factoring the difference of two perfect squares. Thanks for watching.